All right, Caleb, any questions up until now so far?
Nope.
All right. Today is probably going to be a pretty easy day. We're going to be dealing with derivatives again. Um, this time I think we're doing sine, cosine, and some of the natural log and e to the x and some of those. I don't think we're going to hit the quotient and product rule until next week. Let me take a look real quick at the pace chart for this class because I think the product rule comes next week and then the power rule. And those are probably a little bit harder than what we've been doing. So let's see here. Oh, product and quotient rules this week. Okay. Chain rule is next week. The chain rule is the great one. Awesome. All right. Last week we talked about the power rule. First question of the day is, what is a derivative? What is a derivative? Either one of you guys, give me a definition of derivative.
The instantaneous slope of a function.
Okay, so it's an equation that gives us the instantaneous rate of change, or the slope at a given point. That is absolutely correct. So when we find derivatives, there's a reason we're finding them. So we can write equations of tangent lines, right? So now the problems that are up on the board, obviously the power rule is pretty easy, but if you get some problems with fractions in there, a little bit tougher, but oops, my marker's not on here. So if I was going to take the derivative of this thing, and I'll let you guys do the derivative of this one. All right, you guys get this one. I'll take the easy one. So 3 times 2/3 is going to be 2x, and then if I subtract 1 there, I get negative 1/3, minus, and then that looks like a 1/2, so 4 times 1/2 is 2x to the negative 1/2, and then derivative of a constant is just 0. Usually we do not leave negatives in exponents, so I probably would rewrite this as 2 over x to the 1/3 minus 2 over x. I'd probably rewrite it as 2 over the square root of x because the exponent 1/2 is the square root, so that's probably how I would write it. Now, you can write it any way you want. I mean, it doesn't make a difference. I would not mark it wrong if you wrote it some other way. All right, so Henry, you say the answer to the next one is x to the negative 1/2, 1/4 x to the negative 3/2. Okay, so if I was going to rewrite this one, let's see here, I'd rewrite it as 2x to the 1/2 minus 1, well, no, I'd rewrite it as x to the negative 1/2 over 2. So if I bring that 2 down, that gives me x to the negative 1/2. So I agree with your first one. And then if I bring I do not agree with, oh, maybe I do. Okay, so you have negative 1/4. Okay, so, or 1/4, so plus 1/4 x to the negative 3/2. Oh, I agree, Henry, with you 100%. Sorry about that. Very nice. Excellent work. So the power rule is a very easy way to find the derivative of a function, and that derivative gives us a slope at any given point. Now, it's kind of crazy to plug a number in any one of those, so we will not. All right, so now this problem here, it says, what is f prime of 8? A little blurry, but this is f prime of 8. Okay, so give me what f prime of 8 is for the first problem up there. And sorry about the loud noise. There's my next door neighbor is power washing his deck right now. I don't know if you can hear that or not, but that's what all the noise is. But it's too nice outside to close the door, so we'll be listening to a power washer, I'm sure. Oh, you can't hear it? Okay. All right. So what is my answer for what is f prime of 8? (40/3), and you both have 40/3. So I'm going to probably say it's 40/3. So if I take the derivative here, bring the 4 down, that's going to be 20/3x to the 1/3. If I put 8 in there, 8 to the 1/3 is 2. So I agree with you guys. 40 over 3. Very good. Now that problem right there, that is testing a lot of different things. Hopefully you guys did not need to use a calculator. Are either of you guys using calculators right now? Shame, shame, shame if you are. All right, so that kind of tested a couple things. It tested if you knew how to take a derivative. It also tested, did you know what 8 to the 1/3 is? And 8 to the 1/3 is the third root of 8, which is 2. And then we multiply that out, so 40 over 3. How about the second one? What is f prime of -1? Ooh, so Henry, you've got -3? Okay. Caleb, do you agree that it's -3? I've not worked it out yet, so I'm not going to agree or disagree just of yet. But if I took the derivative here, I end up with -3x to the second plus 1 plus, I've got x and -1 there, so I bring that down, -1x and -2. So that's going to be -1 over x squared. So if I put -1 in here, -1 squared is +1. So that's -3 plus 1 plus, I put -1 in here, I get +1, so that's -1 there. I got -4 plus 1, which is -3. I agree 100%. -3 is the correct answer. Very nice. You guys know your derivative. Okay, today we're going to find the derivatives of trig functions, natural log, and e, the product rule and the quotient rule. All right. And again, since you guys had AB Calculus already, or you've gone through AB Calc, all of this stuff should be review material. That's why we go through a lot of stuff right off the bat. Derivative of sine and cosine. All right. So if I have f of x is equal to the sine, then f prime of x is equal to what? What is the derivative of sine of x?
Cosine of x.
Cosine of x is absolutely correct. What is the derivative of cosine of x?
Negative sine of x.
Negative sine of x. And then the derivative of negative sine of x is?
Negative cosine of x.
Bingo. And then it just starts all over again. So if I asked you to find f of x, that really is asking me to find the fourth derivative. Oh, I'm sorry, I should have given you a function. All right, so if I asked you to find f, and that's 4 up there, so, and I could write it this way too. Sometimes they'll write it like this. Basically what it's asking for is it's asking for the fourth derivative of a sine of x. Okay, so if I was going to do that, first derivative is cosine, second derivative is negative sine, third derivative is negative cosine. I go right back to sine of x. So the fourth derivative of sine of x is sine of x. Okay, so those are things that you do need to know. Sine of x, cosine of x. So here is the definition. The derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. Things that you need to have memorized for the AP test. Okay? These are some of the ones that just have to be memorized. All right, Caleb, why don't you take the first problem? And Henry, why don't you take the second problem? Tell me what the derivatives of those are. And you can just say them on the mic. It's perfectly fine. You don't want to type them in. If you can just look at it and say, "Oh, my answer is blah 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 blah," perfectly fine. Let's see here. So Caleb, 2 minus 3 cosine of x. I agree. Henry, 2 sine. Let's see here. So cosine is negative sine, so that's going to be a negative negative. So that's 2 sine of x plus 9x squared. Very nice. You guys know your derivatives. All right, and here are the other trigonometric functions. Okay, the derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant is secant tangent. And the derivative of cosecant is cosecant cotangent. So these are, derivatives that you need to know. Now, when we start dealing with the chain rule, it gets a little bit more, I think it's a lot better, because right now, since we don't know the chain rule, we can't do anything. Like I couldn't ask you what is the secant squared of e to the x. Now you guys probably would know it already because you already know. Oh, I'm sorry, this is not squared. It would just be secant. So what is the derivative of secant e to the x? Well, the only thing you guys know right now is just x. But when we start dealing with the chain rule, we know that you take the derivative and leave the inside alone. So that would be secant e to the x tan e to the x times the derivative of the inside. Well, the derivative of e to the x is e to the x. So this would be my derivative of this thing, which is kind of crazy because it's usually when we take a derivative, we have a smaller function. Not always. Not always. So this one we get secant e to the x, tan e to the x, e to the x. But that, you won't need to know that until next week when we start dealing with the chain rule. I love the chain rule, especially when you have the chain rule inside the chain rule inside the chain rule. Awesome problems. All right, derivatives of exponential functions. Right? What is the derivative if I gave you f of x equals e to the x? What is my derivative?
E to the x.
Correct. It is the only derivative of it. It's the only derivative that is exactly the same as the function. And when we take an integral, it's the only integral that has the same one. So e to the x is just e to the x. So there's our definition of the e to the x. It's just e to the x. You guys remember what this derivative is? Okay, that would be the chain rule again, and that's what we're going to work on next week. So what is, I'm just testing this, how much you guys still remember. What's the derivative of e to the 2x?
2e to the x, or
Correct. 2e to the 2x, because when you have a chain rule, you take the derivative of the function, e to the 2x, which is just e to the 2x, times the derivative of the exponent, which is just 2. So 2e to the 2x. So Henry, you missed the 2x, the power there. It should have been 2e to the 2x. Yep. But that, as I said, that's chain rule. That's next week. All right. So here's 3 problems. We'll go Mr. S. Then we'll go Caleb. And we'll go Henry. And as I said, you can just read it into your mic if you wanted to, or you can type it in. My answer is 3e to the x. That's my derivative. Caleb, 2x plus e to the x, I agree. And Henry, cosine of x. Boom. Very easy when you don't have, when you can't use the chain rule, because then they're all very simplistic. All right, the derivative of natural log of x is 1 over x. That is it. That's the whole derivative. All right, now this uses a chain rule. So do you guys remember what this would be? Natural log of sine.
1 over sine of x times cosine of x.
That is absolutely correct, because the derivative of this, you just take that 1 over, so that's just 1 over sine of x, times the derivative of the inside. Well, the inside of sine of x is cosine of x. So my answer would be cotangent of x. Henry, very nice. Cotangent of x, because cosine over sine is cotangent. And sometimes on an AP test, they'll do that to see if you understand that cosine over sine is cotangent. That's just some of our trig identities. Sine over cosine is tangent. Cosine over sine is cotangent. So some reviewing of trig identities. And we'll be doing that all year long. All right. We'll start with Henry this time. Henry's got the first problem. Caleb, you got the second problem. All right, so now you guys recognize where I get these problems from? These are all from the Khan Academy. You know, when if you're doing the practices or the quizzes, these are I just copy and paste them. So it's like, okay, this is basically what Khan Academy wants you guys to know. So Henry's got 12x to the third, 12x to the third minus 7 over x. That is absolutely correct. Very nice. Let's see here. So Caleb's got negative cosine of x minus, I don't agree with 1/9. I don't agree with 1/9 there. Yeah. you didn't totally mess up, but yeah, it's going to be minus 9 over x, right? Because you're just taking the derivative of the x inside, and that's just 1 over. So the derivative of natural log of x is just 1 over x, and then you've got that 9 still there, so it's just negative 9 over x. Correct. Yes. All right. So now we're going to deal with the product rule. Caleb, you've seen this before. Henry, you probably have not. There's not a whole lot of books that do it this way. Most books deal this way. This is the product rule. d dx of uv equals u dv dx plus v du dx. And that is true. I mean, it is absolutely true. However, I do it a little bit different because it makes it a little bit easier for my small brain to understand. I do it this way. I always go, okay, so if you have uv, then you want to write it out this way. You want to write u prime, v prime. And then your answer is, if you're doing product rule, it's inside plus outside. So you just multiply the 2 terms on the inside plus the 2 terms on the outside. So for an example, if I gave you something like the sine of x times e to the x, okay? And I'm going to use the product rule here. So I'm going to let u be sine of x and v be e to the x. So I'm going to write it down, u sine of x. So u prime, well, the derivative of sine of x is cosine of x. And then my v function is e to the x. Well, the derivative of e to the x is e to the x. So now my answer is just the 2 inside functions multiplied together. So I've got e to the x cosine of x plus, and then the outside functions multiplied together. Sine of x, e to the x. Now I could have put the e to the x in front. It really doesn't make any difference. But that's how I do the product rule. I always line it up, u prime, v prime, because then when I do the quotient rule, then it's inside minus outside all over bottom squared. That's just my mind. That is how I memorize the product rule and the quotient rule. Now, you can memorize it this way, u dv dx plus v du dx. That's perfectly fine. Okay. All right. So here we go. So if I'm going to do this problem right here, I just say this is, now I probably would not use the product rule on a problem like this, and I'll show you why in just 1 second. But I'm gonna do the product rule here. So I have u is equal to 1 plus x to the 1/2, and the reason I do x to the 1/2 is because I know I have to take the derivative. So u prime is equal to 1/2 x to the negative 1/2, and then v is equal to x to the third. V prime is equal to 3x squared. So inside, so I have 1/2 x to the negative 1/2 over x times, okay, so, and I could add the exponents together, which I probably would, and then plus the outside, so this would be 3x squared times 1 plus x, the square root of x. Right? So, and you really can't read that very well, but that's what I would do. But now, if I really had to do this problem, I probably would just multiply through here. So 1 times x to the third is x to the third, plus x to the third times x to the 1/2. Well, the bases are the same. We add the exponent, so that would be 3 plus 1/2. So I would make that 6 halves. So that would be 7 halves. So that's x to the 7 halves. And then I would just take the derivative of this, which I would get 3x squared plus 7 halves x to the, subtract 1 there. What do I get? 5 halves. Now somebody's going to say, oh, your answer is way off, Mr. Schenkel. It's not. If you multiplied this through and simplified it, you'd get the same thing. It's just which way is easier. I think multiplying it through would be a whole lot easier than having to do the chain rule. However, it is a chain rule. I'm sorry, it's not chain rule, it's the product rule. So you can do it either way you want. Okay? And that's why these, when you're doing the product rule, it's better if they gave you problems like this, where you have the sine of something times, let's go natural log of x. Then it's like, okay, u is sine of x, u prime is cosine of x. So that to me makes more sense than doing something like this, because something like this I could just rewrite it as a polynomial function. But either way, it makes no difference in how you do it. I mean, I don't care. That's why when I do my assessments, I usually use sine, cosine, and all that kind of stuff instead of polynomial functions. Because polynomial functions you can just multiply out and you just get your answers. Okay, so now these I like a lot better. All right, so I've got Caleb here and Henry here. All right, let's see what you guys get for those. This is the product rule. Let's see what you end up with. Have you guys been outside today? What a beautiful day. All right, Caleb's got sine of x e to the x, cosine of x e to the x. I agree with that. 5-mile walk yesterday? Yesterday it was raining, wasn't it? Well, yesterday it was raining down here. I don't know where you live. I think you guys both live up toward Green Bay, don't you? I think you guys are pretty close to each other. Okay. All right. So let's see here. Henry, secant, tangent, x squared plus 5 times tangent x 2x. All right, I agree with you. You guys definitely know the product rule. You definitely know your trig functions. Very nice. As I said, first semester, not a real big deal. All right, now, the quotient rule, again, this is the definition our book gives us. Okay, now what I do is I do the same thing. I do u prime, v prime, and it's inside minus outside all over bottom squared. Okay, so let's say I gave you something like the sine of x e to the x. Okay, so I do exactly what I normally do. This would be product rule. Sorry about that. Let's do a quotient rule. So let's say I gave you sine of x over e to the x. Okay, so I do exactly like I do with the product rule. I'm just going to go sine of x. The derivative of sine of x is cosine of x. Then e to the x, e to the x. And then it's inside, so e to the x times cosine of x, minus outside, well, that's e to the x sine of x, all over bottom squared. Well, if I square this, I get e to the 2x. And that is my derivative. That is the quotient rule. So that's why I write it out this way, u prime, v prime, because then when I do quotient or product, it's basically the same setup. It's just for product rule, it's inside plus outside. For quotient rule, it's inside minus outside over bottom squared. Does that make sense? I mean, I don't want to sit here and bore you guys with, all this stuff when you guys already know it, but if it doesn't make sense, say something, and then we'll slow down. All right. So here, this is a polynomial function. Now, doing the quotient rule with polynomial function, it's probably the best to use the quotient rule. So u is equal to x to the third minus 4. U prime is equal to 3x squared. V is equal to x squared plus 3. V prime is equal to 2x. Okay? Inside. Now, some books will make you multiply this all out. I'm not going to. So you got 3x squared times x squared plus 3 minus outside. So that's 2x times x to the third minus 4 all over bottom squared. Well, that's x squared plus 3 quantity squared. Now, I'm not asking you guys to multiply this out. There's no way. I mean, just leave it as is. It doesn't make much of a difference if you multiply everything out and end up with 3x to the fourth plus 9x squared minus, I don't need that. Now, maybe on an AP test, they might have the answers simplified down. I doubt if they would do that also because it takes time. If you can get to this point, you know how the quotient rule works. I mean, that's just the way it is. So just leave your answers. Do not have to multiply them out and simplify. Makes no difference. Okay, we've got Caleb here. We've got Henry here. All right, go to it. Now, Henry's is a little bit trickier because it's a quotient rule, plus you have to use the product rule, don't you? Unless you multiplied it out. I'm not sure how you're doing it, Henry. But you know, it looks like you got a quotient rule there, but it also looks like you'd have to use the product rule over here, unless you multiply this out. If you multiplied it out, then it would just be a quotient rule. But this one's a little bit tougher, no question about it. So Caleb, whew. All right, I did not do this problem yet, but let's do it. U is equal to z squared plus 1. U prime is equal to 2z. V is equal to z to the third minus 5. V prime is equal to 3z squared. Inside, so I've got 2z times z to the third minus 5 minus outside, so that's 3z squared times z squared plus 1 all over z to the third minus 5 quantity squared. Boom. Let's see, is that what you had? 2z, z. Uh-oh. I don't have the same thing you have, Caleb. You have, oh. Caleb, did you copy that down wrong? Because I have 2z times z to the third minus 5 minus 3z squared times z squared plus 1.
So I accidentally did the outside.
Ooh, chin, chin, chin.
So you'd have to flip both of them.
All right, just as long as you understand where your mistake was. Now, I'm not even going to agree with that because you did, I mean, you have 2z and z squared plus 1. You have these two put together, and you have these two put together. You really messed that up, man. Because remember, it's inside minus outside. And that's why I always do u prime, v prime, because then you cannot mess it up. Well, I guess you can mess it up. All right, Henry, did you multiply this out, Henry, or did you do the chain rule with the product rule? Or the chain rule, not the chain rule, the product rule. You did not multiply it out? Ooh. I think I think I would multiply this bad boy out. I would get 2t minus t to the fourth minus 8 minus Oh, that'd be plus 4t to the third. So this would be my bottom. I think I would have multiplied it out so I wouldn't have to do the chain rule. So I would have ended up with u is equal to t squared. U prime is equal to 2t. V is equal to, let's put this in order, 4t to the third. Oh, that's negative. Oh, that's all right. I won't put it in order. Plus 2t plus or minus 8. And then v prime is going to be negative 4t to the third plus 12t squared plus 2. And then inside minus outside all over bottom squared. And I would assume yours is probably right. It's just trying to simplify those bad boys down would take some time. Yeah. All right, Caleb, do you understand where you made your mistake? All right. Now, these are the types of problems on most of the assessments kids really mess up on. Given u equals 3, u prime equals negative 2, v is equal to 10, v prime equals 5, find the answer to each. Okay, I'm going to let you guys do all 3 of them. I'd like you to do all 3 and see what you get for an answer. Okay, the last one is the one that most people get wrong. I don't get it, but hey, that's all right. So what you're trying to do is you're trying to find the derivative of each one. So I want to know what the value of f prime of x is in each problem. Okay, that's what I'm looking for. I want the value for f prime of x. I'll give you a couple minutes to work on those and see what you get. All right, we have Caleb's answers, -5, -7/20, and -6. Now, I don't know what the answers are because I haven't done it yet, but if I was going to do this problem, the derivative, this is the product rule, so I would go u prime, v prime, so u is equal to 3, u prime is equal to -2, v is equal to 10, and v prime is equal to 5. Inside, so -2 times 10, plus outside, 3 times 5, which is 15. So -20 plus 15, I'd come up with -5. So far, so good, Caleb. Now, the second one, since it's the quotient rule, I'm going to do inside, -20, minus outside, well, that's 15, all over bottom squared. Well, v squared is 100. So -20 plus -15, that's -35 over 100. So 5 goes in there 7 times, 5 goes in there 20 times, -7 over 20. I agree, Caleb. All right, Henry, are these making sense what I'm looking for in these types of problems? Okay, now the bottom one, 3 times u, if I take the derivative of that, I get 3u prime. So that's just 3 times -2 which is -6. Boom, that is correct, Caleb. You got it all correct. Very nice. Henry, did you get all of those correct answers? Awesome, very nice. Okay, second and higher order derivatives. We talked about that a little bit in the beginning of class. If I gave you f of x is equal to sine of x, and I asked you to find f of 4 of x, it'd just be sine of x, right? Because the derivative of sine of x is cosine of x, derivative of cosine of x is negative sine of x, negative sine of x is cosine of x, derivative again, sine of x. So you can take more than one derivative. What if I asked you to find f of 10, so the 10th derivative of e to the x? What would my answer be? If I had to take the derivative 10 times, e to the x. That is absolutely correct. Okay? So just because you can take derivatives higher, okay? Because remember, when we take the first derivative is instantaneous velocity. Second derivative, or really the slope, second derivative is velocity, and third derivative is acceleration. So we got all those different things, taking derivatives, and then we have the next one is germ. So all they're saying is that you can take it to a higher order. Whew, that is it for today. I believe you guys will have no problems on the assessments this week because you guys know the product rule, the quotient rule, and what else did we do today? There was one other, no, we didn't do tangent lines. Oh, sine, derivatives of trig functions and derivatives of natural log. Okay, any questions on any of that stuff? All right, you guys have a great afternoon. Have a great evening. Try to get outside. It's beautiful out there today. Bye.